Good morning. Today is the last section in Chapter 7, and we are going to be talking about natural log. Now, natural log is actually on your calculator. If you were looking for it, it looks like an L and an N. So this is that button on your calculator. It's on the left-hand side, down like across from the numbers. A natural log follows the same properties as a regular log. Alright, so let's just review those real quick. So, let's say them this way today. If I had the natural log of x plus the natural log of y, in the log world, when you're adding, you're really multiplying. This would be the natural log of xy. If I had the natural log of x minus the natural log of y, in the log world, when you're subtracting, you're really dividing. This would be the natural log of x over y. If you have a coefficient in front of the natural log of x, that coefficient is actually the exponent. This is the natural log of x to the c power. And the last one we're going to mention, when we talked about logs, it was the log base b of b equaled 1. Here, the natural log and its inverse e, the natural log of e. And e would be raised technically to the first power, so we have a 1 out in front. The natural log of e equals 1. So natural log and e are inverses. Just like we said, exponential and log were inverses, in this one, natural log and e are inverses. And you'll find them on the same button on your calculator. So let's talk about condensing these down into one natural log. So in example number 1, we're using the properties. To write is a single natural log. So if I have the natural log of 10 minus the natural log of 2, in the log world, when you're subtracting, you're really dividing. So this is the natural log of 10 divided by 2. And if we simplify that, that's the natural log of 5. Let's do another one. How about if I had 2 natural log 3 plus natural log 5. Starting at the beginning, this 2 in front, right here, becomes our exponent on 3. So we have the natural log of 3 squared, or 9, plus the natural log of 5. And in the log world, when you're adding, you're really multiplying. This is the natural log of 45. How about one more? 4 natural log A minus 2 natural log B. So we're going to start by taking these coefficients and moving them to our exponents. So we have the natural log of A to the 4th minus the natural log of B to the 2nd. And in the log world, when you subtract, you really divide. We have the natural log of A to the 4th divided by B to the 2nd. So using these properties, we're going to go ahead and solve some equations. So, when solving equations with natural log. Step 1, just like we did when we have logs and exponential, we need to get the natural log term by itself. 2 we're actually going to take and raise each side from e. Remember, e was that inverse. We can do this because it's considered a one-to-one function. As long as we do the same to both sides, keeps it the same. 3. When we have e to the natural log, they are, again, these are inverses, and they cancel, leaving what's behind it. So, since inverses cancels and left with, we're going to say what is behind the natural log. And we're going to explain that a little bit more when we do our first example. 4, we're going to solve the remaining equation. And then step 5, you want to check for extraneous solutions. So when I say extraneous solutions, it comes out to be a solution, but if you were to plug it in, it doesn't work or it makes it a no solution. So let's say in my equation I had the natural log of x, and I find out that x is negative. Well, you can't have the natural log of a negative number, just like you can have the log of a negative number. Alright, so using these steps, let's move to our next example. Example number 2. We're going to solve the equation. We're going to check our answer. So we're going to check for those extraneous solutions. And then I want you to round or truncate. Remember, truncate just means to cut it off to the thousands, which is different than what your worksheet says. Alright, so let's say I have 2 natural log x equals 6. Alright, first thing I want to do is I need to get this natural log x by itself. So I'm going to divide both sides by 2. That leaves me with the natural log of x equals 6 divided by 2 is 3. Now to solve this, we are going to take and raise each side from e. On this side, as we said, this e and natural log technically are going to cancel each other. And we're going to be left with this x on the left. Here, we can either leave it as e to the third, or if we plug it into our calculator, we get 20.085. Okay? Again, you can round or truncate to that third decimal place. Let's try example number 3. Same step. So if I have 4 natural log of 3x minus 2 equals negative 6. So this is all grouped together. That's what's behind the natural log. So I have to get this natural log of the 3x minus 2 by itself. So I'm going to divide both sides by 4. I have the natural log of 3x minus 2 equals negative 6 divided by 4 is negative 1.5. Then, because the natural log is now by itself, I can do that e to the base of each one of these. So e to the natural log, this will cancel, leaving me with 3x minus 2. And on this side, if I type in my calculator e to the negative 1.5, I get 0.223. Then I just want to solve the remaining equation. I'm going to add 2 to both sides. So I get 3x equals 2.223. and dividing both sides by 3, we get x equals 0.741. Now, we can take this and plug it in, make sure it works in our original equation. 3 times 0.741 minus 2 is still a whole number, so this will work. Not a whole number, a positive number, excuse me. All right, let's try example number 4. All right, let's say I have -4 plus the natural log of 2x equals 3. Again, we need to get the natural log of 2x all by itself. So we are going to move this -4 to the other side. So I'm going to add 4. Leaves me with the natural log of 2x equals 7. Now to get rid of that natural log, what do we do to both sides? We take it from e. On this side, the e and natural log cancel each other, leaving us with 2x. On this side, e to the 7th power is 1096.633. Now dividing both sides by 2, we get x equals 548.316. And again, you should check your answer, plugging it in. It's still going to be positive, so we're going to be okay here. So this is a good answer. Alright, so we've talked about if it's got a log in the equation. But what if it's got e in the equation? Alright, so in solving an equation with e, let's talk about those steps. First, step 1, just like we have in everything else, we need to get that e to its exponent, and I'm going to kind of write it with a box there, by itself. Two, we're going to put in front of both sides a natural log. And again, we can do that as long as we do it on both sides. It's a one-to-one function. Step 3, the natural log of e to its exponent. Technically, remember those exponent rules we've talked about. That exponent goes out in front, right? And so the exponent is the coefficient. And I want to remind you that the natural log of e equals 1. Step 4, I'm going to ask you to solve the remaining equation. Alright, so here we go with example number 5. Use the natural log to solve. And again, I'm going to ask you to round or truncate. And again, as I said, this is different than the directions on your assignment, so I want you to do this. To the thousandth. That's 3 decimal places. Alright. If we have e to the x equals 12. Alright, so e to the x is already by itself, right? So what we're going to do is in front of both sides, we're going to put the natural log on both sides of it. Now on this side, technically this x goes out in front. So we have the x of the natural log of e equals the natural log of 12. And this natural log of e equals 1. So we can, x times 1 is still x. And on this side, you can leave it as the natural log of 12, or again, type it in your calculator, round or truncate to 3 decimal places, and we get 2.485. Let's try another one. Example 6. We have 4e to the 2x equals 16. Now we need to get this e to its exponent by itself, so we need to get rid of 4. To get rid of the 4 coefficient, we're going to divide both sides by 4. So I divide this side by 4 and this side by 4, leaving us with e to the 2x equals 4. Then to get rid of the e, I have to put a natural log in front of both sides. Here, this exponent then gets to move out in front, and the natural log of e becomes 1. So we have just 2x times 1, or 2x, equals, typing this into your calculator, the natural log of 4, we get 1.386. Dividing both sides by 2, x equals 0.693. Okay, let's do example 7. All right, so we have e to the natural log of 3x equals 12. All right, well, let's have both already. And if you'll notice in the last sections, right, this e and natural log, they cancel each other. So what do I have left on the left-hand side? I just have the 3x equals 12. Dividing both sides by 3, and x equals 4. All right, so just a couple of quick notes. Yeah, put them down here. A couple of quick notes. First of all, I want to remind you that you cannot have a natural log of a negative number. This would be no solution. All right, that would be an extraneous solution. And number 15, again, I have a typo. Sorry about that. Number 15 is a typo. The correct question is e to the x minus 1 equals 50. And if I'm going to solve for x, I have to first move this 1 to the other side. So I'll have e to the x equals 51. And then I just natural log both sides and go ahead and solve it. If you have any questions, let me know. This is our last lecture of the school year. And we're going to move forward with review. And I will talk to you guys soon. Have a great day.